Acanthocystis species, Part 2. Note that the organism is a heliozoan actinopod with a spherical body covered in scales and numerous long, narrow projections of several varieties. As noted previously, there are many photomicrographs and drawings of Acanthocystis to be found in the literature and on the internet. Acanthocystis is of the order Centrohelida and resides in its own genus, Acanthocystidae. The diameter of its body is approximately 35 microns. It has an amoebic cell body which is covered with a cuirass of siliceous scales, scale spines, and spicules. The pseudopodia of Acanthocystis are known as axopodia. They originate at a central location in the cell, the axioplast or centroplast. The axopodia are radially projected through openings in the cuirass and are extended for a distance of 20 or 30 microns or more. Since the center of the cell is occupied by the axioplast or centroplast, the nucleus is eccentric in location. The outer surface of the body of Acanthocystis possesses numerous flat, sharply ellipsoidal scales, which are closely adjacent or overlapping or tangentially positioned. Unlike marine radiolarians, which it superficially resembles, Acanthocystis does not have a rigid internal siliceous skeleton. Thus, it is able to a limited degree to change the general outline of its shape, presumably sliding and moving some of its scales and spines in the process. Here, the organism on the viewer's right seems to have squeezed itself a little bit in passing between two promontories, while the one on the left has a little nubbin at about 11 o'clock. Here on the viewer's left, the organism has developed a pointed projection as it passes through a narrow space, and the organism on the right has developed a rather prominent nubbin at about 5 o'clock. It is possible that the organism on the right is budding. Acanthocystis has numerous glass-like spicules which originate in plates on its surface. As can be seen here, the spicules vary in length, and at times they can be broken or fractured. The distal tips of the spicules can be bifurcated and Y-shaped, as they are here, or they can take the form of a flat nail head or a crescent. This feature is species dependent. Note that some of the spicules appear to have bluntly rounded tips. This appearance may be artifactual and may actually represent the angle at which the bifurcated tip is being viewed. Note that although the spicules can be of long, intermediate, or short type, the Y-shaped tip is the common configuration. It seems likely that the organism depicted thus far is Acanthocystis terfacea. This slide shows a direct comparison between the diagram in John's textbook and two photomicrographs. Note the great similarity. The diagram is that of Acanthocystis terfacea. The somewhat nondescript clear globules contained within the axopodia are extrasomes. In this video, they can be seen moving up and down the axopodia in a somewhat random appearing pattern. Extrasomes are extrusable organelles which can be used to penetrate the pellicle of organisms such as ciliates, which are preyed upon by heliozoans. In this video, in which black and white have been inverted, the extrasomes can be seen as gray or blackish objects which are moving up and down within the axopodia. In this video, the heliozone closely approaches the side of a paramecium, and the heliozone extrudes a cytoplasmic peduncle, which does not succeed in penetrating the paramecium's pellicle. The paramecium got away. Numerous endosymbiotic zoochlorella can live within the cytoplasm of Acanthocystis. This is the reason why the organism is often referred to as the green sun animalcule.